Okay, so continuing on with factoring polynomials, we're going to go over various methods for factoring. So some of this may be review. So we're going to start with a review of what is a polynomial. Well, a polynomial is a single term or a finite sum of terms. Okay, so a single term, one, or finite sum, a sum of several terms, in which all variables have whole number exponents and no variables appear in a denominator. Again, whole number exponents, so the exponents of all those variables are not going to be negatives or fractions. We're going to have whole numbers. Okay, review. What is factoring? The process of writing a polynomial as a product, that's what it is called factoring. Okay, so breaking something down into products, things that get multiplied. Okay, a polynomial is completely factored when each of its factors is prime. So if you think of what is a prime number only has one and itself as factors, no other factors. So once something is prime or a polynomial is prime, we cannot break it down anymore. Okay? The greatest common factor, okay, greatest, or the GCF, is the greatest factor that divides the numbers. So again, every number can be divided by 1, but we're looking for something greater than that as well, okay? More review. So remember that factoring out any common factors is going to be the first step when completely factoring a polynomial. So it can also be thought of doing the distributive property in reverse or undoing the distributive property. So we have an example here, AB plus BC. If you have this expression, notice that they're going to have the A's in common, right? So we factor out, pull out the A's, divide by A. So we write that common factor there, open parentheses, and we write what's left once we divide by that common factor, divide by that A. So we're left with the B plus C. So that's how that one would be factors. Now remember that if we cannot factor a polynomial, we will say that it is prime. Okay? So, how is factoring important? Where else is it used? Well, factoring helps us to find solutions of polynomial functions, okay? So, we can also say that we're looking for the zeros, x-intercepts, or roots of a polynomial function. So, these all mean the same thing. So, the application for factoring, again, is to find solutions, roots, x-intercepts, or zeros of our polynomial functions. Okay, so let's look at some of these examples. Step 1. So whenever you are asked to factor a polynomial, remember that the first step, the first thing you always want to do is look for a GCF other than 1, and we would factor out that GCF, okay? So let's look at example 1. Factor each expression. So A, 5x minus 10y plus 25. What do they all have in common? Well, again, I like to look at the number parts first, or the coefficients. So let's look at that. We have 5 for the first term, minus 10, and then 25. So looking all at those number parts, you can see that they all have a 5 in common because I can divide all of them evenly by 5. Okay, so now let's look at the variable parts, right? So I have an x, I have a y, but I actually don't have any variables in that last term. So remember, in order for it to be common to the polynomial, it has to be common to every single term. If they don't all have the same common factor, then we can't use it, right? So even though some of them might have a common term, if not every single term has that common factor, then we can't use it. Okay, so we have a 5, so I'm going to divide all of these by 5. So I write my GCF, open parentheses, and after the parentheses, I write what is left after I divide everything by this GCF, which is 5. Okay, so the first term, 5x divided by 5 is going to give me 1x, or just x. 10y divided by 5. Well, 10 divided by 5 is 2, so it becomes minus 2y. And then 25 divided by 5 is just 5. So we would check that what's left in parentheses can't be factored any further, and this one can't. So I'm done and I leave it. I factored out my GCF, and that's as far as we go there, okay? Okay, let's look at the next one. Again, let's look at the number parts. In front of x to the third, I have a 1. So again, I'm looking for GCF bigger than 1. I already know that that's just a 1. I'm not going to have anything bigger than that to pull out because that doesn't have anything else to pull out besides a 1, right? So I'm not going to have any other number in common. Well, let's look at the variables. I have an x to the third. I have an x squared. And my last term has no variable parts. So I don't have any variable parts in common. I don't have any coefficients in common other than 1. So I can't factor anything out. The rest of the polynomial, what's there, cannot be factored any further either. So I say that this polynomial is prime. Okay. So we can move on to our example C here. Again, let's look at all of our coefficients or our number parts first. 16 in front of x to the fifth, 4, 36, and 4. Now, hopefully you can see that what they have in common is a 4. All of those numbers can evenly be divided by 4. Now, looking at the variable parts, I already noticed that that last term doesn't have a variable part. So there's definitely nothing to pull out from that last term of a variable. So again, they all have to have the same factor. So even though all the other terms have x's, because that last term doesn't, I don't have common variable part to pull out. So my GCF for this one is just 4. So I write GCF, open parentheses. So now in parentheses is going to be whatever I have left after dividing that expression by that GCF, or 4. So let's do that. 16x to the fifth divided by 4. Well, dividing the 16 and 4 gives me 4. So 4x to the fifth. 4x squared divided by 4. Dividing the number parts is 1. So I get 1x squared, or just x squared. 36x to the third divided by 4 is 9x to the third. And then the last term, minus 4 divided by 4 is going to be a minus 1. Okay, so that's how I would factor that last one. So again, remember that when factoring, your very first step is to always check for GCF and factor it out.